No Gatekeeper here. Got started on this Silver Eagle 350 here, which is in fairly good condition. And the fella basically just wanted me to go through it and beef it up if possible. Just basically do my thing with it. Anything I see that needs to be done, do it. And I'm not the biggest fan of the way they have these set up internally. So I'm actually going to do something about that now, which I have done in the past, which worked out pretty good. Another thing I'm not a big fan of is all this wire just literally hanging over the RF circuit here. I don't like that at all. A lot of people wouldn't go to the extra trouble, but I'm just going to go ahead and reroute that wire and replace it with Teflon. Also, stuff gets hot in here, man. This stuff's melting. Then you'll have some shorts and DCs touching the RF ground and stuff. It just ain't good there. I already replaced the feedbacks. Not feedbacks, the balancing resistor. Sorry about that. One of them, the output's pretty much was charred. Let's see, where's it at? Might have done thrown it away and chunked it. There it is. Just the output's pretty much charred. This is one of the only amps I've seen do this way. They actually put 180 ohms instead of hundreds on the balancing. Not too sure what the mathematics is behind that, but that's what they do. So we're going to do a couple of changes to this, man. I've already took the trimmers off the output. And I think that's where the imbalance was, man. You got almost 120 picofarad difference of each on the leakage capacitors out there. That's just crazy. But anyway, we're going to get this thing straightened out for you, bud. We'll be back with it on the test bench. Alrighty. All done, man. Got this thing sewed up, as I like to say, for you, man. We went through this thing and just put a little bit of touch to it, brother, and done a couple of things that I prefer with these Silver Eagles, and a couple of things I think that should have been done from the factory, like all the wire that was non-Teflon wire that was hanging over the circuit and stuff like that. I'm not too big of a fan of that. We replaced all that with Teflon, as you can see. All this blue wire is rerouting all that. Instead of going here to here or here to here, we've rerouted it around the box and up under the box as well. Up under the board as well. So did a couple of circuit changes as well, man. This comes with a 5-and-5 ratio, which is a can't remember the ratio of that, the actual turn ratio in ohms. But anyway, that's beside the point. I went ahead and dropped that down to a 4-and-4, and there's your excess wire for me doing that. Okay. I'm a big believer at not leaving trimmers in a box. The reason be, the second that somebody takes a flathead and turns one of these trimmers, I mean, you're in trouble. You really are, because you don't know where it was at before. You know, it's best to get it tuned, pull it out, mic it in. At least you know it can't be changed, da-da-da-da-da-da. So that's what I went ahead and did, is take these out. I mic'd them in. This was a trimmer right here that was on the output. I retuned the output and the input. Actually, it didn't. These amps do not come with an input capacitor, which is pretty wild. So I tuned the input and the output, and as you can see, it's now got an input cap. You know, it tuned out right there around 56 picofarad or so. So it did need it, especially after the tune just changed it in the circuit a little bit. It definitely needed it at that point. The only other thing that I probably could have done, but I just held off on, is maybe some feedback circuits. I noticed that afterwards, but you know, seems to be doing well, working well. You've definitely gained some power. I should have showed a video of it before. Another thing I went ahead and did is they had non-Teflon wires going over here to the high-low switch, which pretty much is a 100 ohm setup there with a straight wire. I went ahead and put 50 ohm cable in here for you, bringing that back and forth. That tends to help sometimes with a little bit of RFI, you know, that wire being right there around all that DC all jumbled together, you know, just keeps things neat and you know, a better possibility of not causing any extra interference. And another thing that I don't like about these boxes usually that come by factory is the SO239s are on this back plate, okay? Well, over time, you can get a little bit of corrosion and stuff. Anytime a metal that isn't of the same metal is together, corrosion, oxidation, so on can happen. And then once that happens, this is no longer grounded to this heat sink, and now you don't have a ground connection at your coax. And you got to think about it like this: this coax is supposed to come in this amp and back out the amp. You got a shield and you got a center conductor, okay? Well, if this coax is coming into the amp and for some reason their shield, which is the ground of it, is not being connected to this side of the coax, at that point you have a break in the connection of the coax, of a ground, of a shield. At that point, this shield from here onto the antenna means nothing, because it's no longer shielded to your radio. You see what I'm saying? So that can cause a lot of problems, SWR, RFI, and such. So I try to watch out for that kind of stuff. And when I see one that doesn't have grounds going from the SO239 to the board, I just try to go ahead and do it anyway. So that's what we went ahead and did for you. I've done that with the last couple as well that I've done. Just trying to go through everything. They come with 180s for the balancing resistors here, which is kind of unique. That's about the only amp I've seen that does that. I went ahead and, this one was almost blown, man. Almost blown. It had gotten real hot from an imbalance of these two 2-pill sections, which I quickly figured out why that was. So I went ahead and replaced those with 2 new 100s. Okay. I replaced all the 18 ohms to 10 after changing the circuit a little bit. And I gave you a better, stiffer power connection to the output transformers. The way they got the output here, basically the transformers are sitting on the hot bus pretty much. But the way it's set up, this transformer here pretty much gets less current than this one, the way it's set up. They don't give you a lot of room to do it a little better than this. So I just strengthened that up, connected that to that instead of this being flowing through this right here to power both transformers, okay? This right here, this little probably 24 gauge, 22, probably 22 gauge it looks like, was powering both transformers. You come in with this thick wire, okay, with 8 gauge, I think it's 10 gauge. Then you go to this right here to power both transformers. I don't like that, man. It's just makes me feel better to stiffen that up, so that's what I did. I replaced your diode too. This don't come with this factory. Somebody put that on there. I don't know why. Maybe there was a diode that was took out. I just put me a button diode on there for you, man. It's pretty much the same one old Texas Star uses. I got a good bit of them, man. They are they're rugged as a piece of steel. Went ahead and threw your 680s on the output transformers, and like I said, tuned it out, man. And she's working real well, man. Got a little bit of input reflect out. The other thing I didn't mention. This box comes with 470s on the LEDs. Now, that's absolutely perfect if this box is only going to be ran on pretty much 13 volts, 14 at the most. And that's all these boxes were ran on back when they came out. Well, these days you have people running unregulated supplies, so on. Like I'll be hooking up to the unreg supply here in a bit. So I went ahead and changed those resistors out to 1Ks just to be a little bit, because I've seen them blow time and time again on these amps, man. People just hooking them up on you know, nothing wrong. Just hooking them up on a little bit higher voltage, 15.5. We'll take them out eventually. So, yeah, there you go, man. All right, man, let's get this thing hooked up. We'll hook it up with a bench radio first, 4 watts in. And we'll change power supplies too, man, and let you see the max end of it. So let me get all that ready to go, and I'll be back. Alrighty, we got everything fired up, man. We got it on 15.5, 15.6 volts. The only other thing I didn't mention was I also replaced the wire that was coming from here, which is your output wire from these relays. And did have a wire just kind of floating over here to the output. I replaced that with a 50 ohm coax as well. And the only other thing, of course, you probably can see is I cleaned this cotton picker. I like to call, I Q-tip the heck out of it. Cleaned all the flux out of it for you, man. That's probably about an hour job just in itself. And I mean, I just like the clean look after a nice repair like this. It's just something personally with me. I just don't like seeing all that flux all in there. You know, I won't do that with every amp. It's all about really what the person asks for. And as you see, Mr. Charlie, you said tune it back to what it's supposed to be, fix anything found, and beef it up if need be. So beef it up if need be, pretty much. I dropped my dang notebook here. Oh. So that's what I did for you, man. And I pretty much hit the reset button, gave you a nice good clean. I even cleaned the power wire for you and got all the dirt off that for you too, man. So you got a nice good reset, and I also cleaned the top. Couldn't get that off. I don't know what that is. I'll tell you what, man, this thing is in such good condition. If you throw you a good coat of paint on this top right here and on the inside too, I mean, this thing will be superior. Superior. That's all up to you, of course. Alright, doing it with the bench radio first. The box had about a ½ watt worth of reflect on the input before I retuned it and everything. Okay, we're on low first. We'll just show you on low real quick. RMS 1000 watt slug. Looking at the bottom scale, the 100, 20 is 200. Yeah, that's about 50 bird. Okay, 50 RMS. Here's your peak. Yeah, about 200 watts. Okay, that's 4 watts in, 4 watts RMS. Go ahead and, that is a cigarette, by the way, ain't nothing smoking. Go to high. RMS. Right there at 100 RMS. 100 watts. Here's your peak. A little bit over 300 watts. Okay, here's your input reflect. This is at the radio before the amp. 10 watt slug in reverse. Ooh yeah. Ooh yeah. Beautiful tune. Ooh yeah. If you turn that around, it's going to show the radio, of course. So here's what the radio is looking like while driving the amp. Ooh yeah. See, my radio actually increases a bit. It does 4 watts with the amp off, and while it's driving, usually it'll gain about a ½ watt usually. Ooh yeah, there you go. 4.5 watts RMS. Turn the box off. Ooh yeah, a little bit over 4 RMS. Ooh yeah. See, it gains just a little, and that's what you want when you're using a radio. You don't want it to fall back. And maybe a few of y'all should take a look at your radios while you're driving, because some of them radios out there, man, will fall back like all. Sorry about that. I ran out of space, man. I've got to get me a bigger SD card. But I cleared up a little space. I got about 4-5 minutes left, so I need to head on, get this video done. Get my butt in the bed too. Alright, here's what I'm gonna do now. Let's see what the max end of this bad boy is gonna be. What I'm gonna do at this point is I'm going to hook the hot radio up, which we're going to be doubling our input from 4 watts RMS to 8. That's about 18 to 20 peak to about 40, okay? 35, 40 peak. And I'm also going to hook it up on the unregulated supply. Why? Well, one reason is this bad boy turns that one off, puts an overcurrent protection. So we'll be back. Alrighty, Mr. Gatekeeper back. We're on the 100 amp supply on the medium tap, floating at 18. We're on the Stickman modified radios doing 8 watts RMS. Okay, and I will mention one thing. I'm starting to have people kind of ask about it. Why don't I have a meter hooked up that shows the output reflect? And it's a good question. I just hadn't got around to doing that, which I am going to do. I've been supposed to have been in pretty much my new shop by now. I think I was kind of holding off on doing stuff like that. I guess, changing around stuff till I got there, but I might do that before I do. And I just need to get me a connector. I do got another bird meter over there I can use that for. But a lot of people will argue with you and this and that. Most people out there are showing you the output reflect on a dummy load, and that is not the absolute most accurate way to show the output reflective of an amplifier. The best way is, that is a great way to do it with a low watt slug, no doubt, but it's just a resistive load. The absolute best way to do it is on an absolutely perfect 1-to-1 antenna. That's how you can really see, but of course it still can vary from station to station with different lengths of coax. You get velocity factor that plays into that. So, I think a lot of people just would rather do it with a load and leave it be, but I plan on doing both. I don't care if I got to get a dang antenna out there and play around with it till it's absolutely perfect on the MFJ and on 2 or 3 other different types of analyzers. I want to show both. Okay, and here we go. 8 watts in, 1000 watt slug, RMS. Ooh, right there at 180 watts RMS. Here's your peak. Ooh, almost 500 watts. About 480. You would not have seen that out of this box without doing the couple of changes that I did. About the most I could get out of it at that point was about 400. That's about it. So, you gain 80 watts. It ain't much. But, it's gain. And that is dropping to 16 volts, which is a little hot. A little hot. I would not be running this box on 16 volts, but it is Class C, so it's all up to you. I'll leave that up to you completely. And just for the heck of it, do a quick burp on some big volts, which a lot of people don't like me doing this. But we'll just do it real quick. 200 watts RMS. That's sitting at about 18 volts, almost 600 watts. And I will repeat, no, do not run it that way. I'm just letting you see the max end of the amplifier. No one's supposed to run their boxes that way, but hey, we still do. Some of us do. I don't. I like to run about 60%. All right, y'all. God bless. 73rds. Got a couple more videos to do. We're gone. Bye-bye.